Alrighty. So this talk here started on this journey about a year ago, putting together this JDBC driver. I know a lot of the guys who worked on this before me are in the room, so hopefully do them well, and they have some good insights as well. So a little bit about me. I've been working with Solr for 3-4 years now, but also been doing Hadoop and search as well for about that same amount of time. And I've been contributing patches to open source for a long time. So this JDBC piece is kind of a culmination of that and kind of being able to connect a lot of different tools to Solr where you really wouldn't think that it makes a lot of sense. So I'm going to give the background of kind of where this came from, a use case kind of showing how this makes sense. The JDBC driver itself, a little bit of the internals, not too much. And then a whole bunch of demos to kind of show what we can do with this without any extra work. And then revisit the use case and then some future developments and improvements that should go in relatively quickly with people helping out. So what is JDBC? JDBC, this is taken from Wikipedia originally, and then it's on Oracle's documentation as well. The JDBC API is a Java API that allows any tabular data, especially stored in a relational database. I highlighted relational database there because that's not entirely true. The way I think about it is a JDBC driver converts SQL into a backend query, wherever that backend query really is. And so I'm going to show how we can use this idea to connect to Solr and answer questions that you may not have been able to answer before. So why should you care? So this is kind of what I really want to focus on. SQL skills are prolific, kind of by a raise of hands in the audience. Who here has done a SQL query before? All right, great. All right, so everybody's at least awake this morning that you can answer that question. JDBC drivers exist for most relational databases and also a lot of NoSQL databases now. And existing reporting tools work well with JDBC and ODBC drivers. Solr 6 has SQL capabilities and works with existing JDBC tools. This has been out for months now, and I'm finally getting around to doing a talk on it. But the Solr Ref guide has some already steps in there on how to hook this stuff up. So here's a use case that I want to walk through, and I definitely took this from the Cloudera blog. They did a great job when this was put out and what was the state of the art at the time. And this is utility rates from 2011, basically for the US, and they wanted to know these 4 questions, and I put them on the slide here. They're not hard questions to answer, but how would you do this in Solr? So I'll give you about 10 seconds to think about how you could answer these, okay, with your current Solr installation. And here are the 7 things that I came up with, also from the blog, that would make this possible with Solr 5, okay? And you can still do these in Solr 6, but facets, filter queries, filters, grouping, sorting, stats. You string 2 queries together, you get the answer from one, go and query again. It's really not that easy. Why are these questions so hard to answer in a search engine that can do so much? So I'm going to show here what some of these queries are, and these are taken directly from this blog. The first one, how many utility companies serve the state of Maryland? This turns out you have to do a select with a state Maryland, and you have to group it, and then you have to grab it, and then how many group limits. I'm like, oh, this is so complicated for why are we there? All we wanted to know was a count where something is equal to the state of Maryland. Not too hard. Cheapest utility rates, again, another group by with a sort. And they kind of get slightly more complicated the more you go down this list. Again, these questions are, what is the minimum, maximum, how many, and what's the cheapest? Really not anything groundbreaking. And so is there a better way? Can we do something with the existing data that we already have and answer this in a better way? And I'm going to kind of throw that question out there, give you a little bit to ponder it, and I'll come back to it in probably about 20 minutes. Okay. And this is going to give you a little bit of a hint on where we're going. But Solr JDBC, some of the highlights. It is a JDBC driver for Solr. It is not the most full-featured JDBC driver right now, but it gets the job done, which I'll show in a second. It's powered by streaming expressions and parallel SQL. There were 2 talks yesterday, one by Yannick Seeley about parallel SQL and analytics, and there was one by Dennis Gove, who's in the audience as well. He did the streaming expressions. These both power what the JDBC driver does. My part was really easy when I kind of put this all together once the rest of that was already in there. But we keep improving those 2, and the JDBC driver kind of gets it for free, which is awesome. And this integrates with any JDBC client, any with a pretty big asterisk next to it. It's all the ones I tested in the presentation. But I was able to just kind of like poll people and be like, hey, what tool do you use? And then hook it all up, and it mostly works. The usage is pretty straightforward. The JDBC prefix is JDBC : Solr : // and this here needs to be a Solr Cloud instance right now. And hopefully that'll improve in a little bit. But you take your Solr ZK connection string and what collection. There's more options you can pass to this, but I'm going to refer to the reference guide for that because it really doesn't add anything to this presentation. So a little bit about the architecture of how this works. It took me a while to come up with this picture because debugging this was not the easiest. But basically on the left-hand side in the orange there, that is on your client side. That's in the JDBC driver itself. All the things in blue are the JDBC spec implementation classes, which is way more complicated than it needs to be for many things. The things in blue in the orange box, those are your streaming expressions, but on the client side. And they're just really kind of talking to Solr. And the purple box is really just a standard Solr client. Nothing fancy there, your Solr J Solr client. And then on the server side, the /SQL handler takes these requests, parses it, and then generates some number of tuple streams to answer the query. And then the response is all streamed back. Basically what we're doing is we're wrapping this in a stream, asking query Solr for it, getting a stream back, and then unwrapping it and pushing it back into a JDBC framework. This works really well because Solr can give you things that look like rows and columns. It doesn't really seem like it when you get your results set back, but you kind of just like rotate it a little bit and voila, rows and columns. So you think of fields, those are your columns, and then all the data that's in your result set would be what's in your values. The idea of a table here is what is a collection for the most part. The idea for databases, which isn't fully fleshed out yet, is going to be Solr clusters. But that's something that would be really cool, that you can just say cluster A dot table name, and then boom, it'll go grab it for you. All right, so here's the things I want to kind of show off in this. We have a bunch of programming languages. I basically took anything that'll take a JDBC driver and hook it up. This includes Java, obviously, Python and Jython, R, and Apache Spark. I don't want to step on the Spark Solr stuff that Tim Potter worked on because it doesn't do the exact same thing. This one here is going to do more of a push down, get a kind of a query response. The Spark Solr piece that's worked on at Lucidworks is more of a export the whole result set to be able to do machine learning and stuff on it. That's not really what this is for. It's kind of a little quicker analysis than that. A couple web things. Apache Zeppelin is a notebook to be able to do analytics. I'll kind of show some notebooks there. RStudio showing that you can go kind of pull this up R in a better web UI type thing. A GUI level thing. So a couple of clients I work with, they use DB Visualizer, Squirrel SQL, or a couple other tools. These are going to be your GUI tools. These are, you can actually type your SQL in there, hit go, and get a response back. And a little bit of ODBC. I have an asterisk next to Tableau because we have a couple things that we need to work out to get that to work right now, but it is actually connecting and then erroring out later. But it's there. I have a patch that makes it work. I just didn't have a time for the presentation. So Excel works, so it actually proves out that the ODBC JDBC bridge is working that I have hooked up, but Tableau just tends to be more finicky than that. Best part about this is all in Docker. So I kind of threw this all out there. It's all on GitHub. It's all built, and I'll show a little bit in this in a second. You can run this on your laptop. I'm running it on my laptop, about 2 gigs of RAM. So kind of keep that in mind as I kind of show some of this performance moving on, because this, I couldn't tell, like I hit go and it comes back. So yeah, let's show that. So like I said, this is all on GitHub. All of the different pieces are there. This is what I use to test the JDBC stuff as integration testing. It is all hooked up to Docker Hub to be able to build all of these different tags. And I'm kind of cheating on some of these. The tags aren't meant to be used for this, but it works fine. So I rebuilt all of these to strip out everything that wasn't necessary. So these are all really minimal examples, so you don't have to download a bazillion megabytes just to kind of show a demo. And this is all hooked up to Travis CI. So this is actually every time a nightly build of Solr goes out or I update one of the images, this runs. I kind of wanted to show this off. It's kind of ugly to read, but that's okay. So you can see here's the Java example, and we ran a query and printed some results. And this just goes on and on. And so I'll show like an example of something that's broken, just so to show that I'm not getting. Right now, this is an error in the Spark piece because we don't support 1 is not equal to 0. There's a JIRA for that, but that happens. And eventually, we go all the way to the bottom. And you'll see it prints out what failed. So right now, we have Spark 2, Spark, and then the SQL line piece. We have some queries in there that don't actually work. Coolest thing is I can actually check this for regressions every time I test something. I can kind of push up a branch, and it'll go and run this, and I'll know what actually works or not. And these are all linked from GitHub as well. All right, so off to the cool demo piece. Other than looking at text, it's not that exciting. So I have Solr running, and I loaded some data in here. I have a test collection, which is what the thing I just previously showed is on. It's got 5 rows with some dynamic fields, some predefined fields, integers, text fields, nothing too exciting there. And I also have the rates data set in here. This is the 37,000 or so records that are from that 2011 utility rates data set that I'll kind of show in a second here. All right, so we'll pick on Zeppelin first, just because it's here. So as I said, like all of this stuff is all running in 2 gigs of Docker with Solr as well, so it all runs pretty quick. This here is a Zeppelin notebook that is running a bunch of queries, and I'll kind of scroll down here. You can see we have a select field A, field B, limit 10. You could say we get our data back, kind of not too exciting. But now we have our dynamic fields are getting pulled back as well. We scroll down here, we'll see field A has a minimum of field C. So we can do our little bit of our aggregates here. So anything that the parallel SQL interface supports, we can just kind of run here, and it'll come back, and Zeppelin knows what the right thing to do based on the JDBC types that we're returning. And these queries get a little more complex as we get to the bottom. It doesn't want to scroll. At the very bottom here, we have bins and maxes and averages and sums, and we could basically go through these charts here and configure them and give you all nice little pretty charts. Again, this is without knowing anything that Solr is running in the background. If you basically give somebody a schema and said, here, go, you could basically get some really cool insights out of this. If I go to RStudio, scroll down on this. There's a simple R script for this. The class path stuff is just because I'm running in Docker. But if I select that and hit run, you'll see that it comes back with the results. And most of that time is actually in the connection, not actually in the query. We can actually run multiple queries and it comes back really quickly. So again, we can run in R the same kind of queries. We can kind of go to town and just write query, and figure out what's up. These here get returned. Right now I'm printing it, but you could actually store this as a variable, as like a data frame, and then go crazy on it. The SQL tools that I want to show here, this is DB Visualizer again. We can basically change these up on the fly. erase this. And if we run this, yeah, there we go. And that's how quick this is. This one's here is on 5 rows, and I'll show an example in a little bit that's got way more rows, and it'll come back really quickly. So we could sit here, experiment with this all day, and give this to an analyst who can come back and find out what's in your Solr index and do all these really kind of fun queries. Again, nothing special about Squirrel SQL, same idea, and it just runs. The coolest piece was when we got the ODBC connector working. Basically, I have an ODBC to JDBC bridge in here from OpenLink, has their trial on it. But it should work with any Java 8 compatible ODBC, JDBC bridge. This is all set up behind the scenes, and you can see these are the collections that I had. You can see this is a test field. One caveat I want to throw out there, because the default when I click in here is a select star. A select star right now is not supported. It's going to be fixed pretty soon. But basically, we could take whatever our query we want, same one we ran before, hit the run button. Maybe. Sure. Connect. Okay. Oh. I'll do it again. So if you were to take this up, I'm going to go to my TSN that I already created, hit connect. Yeah, most of the time it's in the connection for some reason, but test and you'll see that this comes back with whatever data we asked it for. So we can go in and grab all sorts of different data and then return it to Excel with our connect. And you'll see that this data just instantly popped in there. We can hit the refresh button, and if you were to actually change the data in Solr, you can get it back in Excel. So you could power all your charts and graphs and all these other kind of fun things off your data set. All right. Any questions so far before I move on? Yeah.
So I was in this reading instructions thing yesterday. One thing that I gleaned off of this, I'll correct me if I'm wrong, but in order to do, obviously to return any of those values or to do group bys and things like that, you now have to store the values in your index. Is that correct?
You do not have to store it. It depends on what type of query you run. So if you do a limit query, it's actually using the select handler under the scene, so you can actually get back stored fields and all this other kind of stuff.
It doesn't have to be stored.
Correct.
But if you're going to return values,
Yes.
right?
Yeah.
Or if you're going to do a group by, say.
Yeah, so there's a couple caveats here, like about the actual SQL piece, and I really didn't want to spend a ton of time on it because I wanted to rely on the other presentations that happened. But there's the export handler, and that requires like doc values, and there's a couple different caveats for what can be returned right now. And we're talking about how to fix some of that, especially related to multi-valued fields. But I'd love to talk to you afterwards about some of those details. Yeah. Yeah.
Do you have a documentation for what kind of queries
Yeah, so the Parallel SQL reference guide page is not fully up to date. Like as we added things, we never got back and figured it all out for what's there. So it needs to be improved. So it's kind of there, but it gives you an idea to kind of try it and see what happens, and then you're good to go. I'm going to give one more question, then I'm going to keep going. And so.
Can analyzing field use in their condition? Analyzing field.
Yeah, so like an analyzed field or whatever, you can run a regular Lucene query the same as the Parallel SQL stuff. So you can do basically a quote, like where field equal and then quote, and then an arbitrary Lucene query in there, and it'll give you a result back.
Analyzing field SQL equal condition means searching.
Yeah. So like the mapping on a where clause would be the field name equal to whatever the query is. And there's something I just merged the other day that is, that'll support the greater than, less than, greater than equal, and all that kind of fun stuff for primitive fields as well. Okay. So this here is the same example that I gave about 10 minutes ago or so. So these queries were really kind of hard to come up with, even if you had been using Solr previously. So is there a better way? I say yes. Let's use SQL for this. SQL works great for answering queries that are pretty straightforward like this. This is not what Solr was originally designed for. A lot of people are inserting data and they just want to know what's in there before they then return the results normally. So these queries actually become really easy in SQL. So how many utility companies serve the state of Maryland? We can get the distinct utility names where the state of Maryland within a couple characters. How about the cheapest utility rates? And these queries are all valid queries in Solr at this point, and I'll show that in a second. So we can grab utility name, the minimum, we can grab the state, we can group by, we can order by, and then limit one. And get back the result there. Minimum and maximum, where res is not 0. I know it's a weird way to write that one. That's fixed in that latest merge I was talking about. And this one here, the last 2 questions from the blog post, you actually take the result of the 3rd one and put it into the 4th one to get an answer. You don't have to with SQL. This will just give you the right answer that you were looking for. So what does this actually look like in, I'll pull up a Zeppelin notebook for this. So what we can see is this here is those 4 queries right there. And if I hit the run all paragraphs button, you'll actually see that this did just run. You may have blinked and missed it. But this here is going against 30-something thousand records. And you didn't even see it happen. It just gone. Like I said, it happens really quickly. And this gives you the same answers that they got in the blog post. And I actually manually verified that this is correct as well. So we get the mins, the maxes, we get state and zip code as well. So again, this will be in the slides as well. All the demo stuff that I demoed today, I have some hidden slides in there, but I'll turn them on before I publish it so you can actually see this all again without having to look at the video. So some future development and improvements. The biggest limitation we're hitting right now on the parallel SQL side is the Presto SQL parser that's behind the scenes. Right now it's really hard to extend for some of the use cases that we really want to get to. So I've done a little bit of work on this, getting Apache Calcite in there. This should give us improved SQL compatibility. It should fix most of the things like nested queries that don't work today. We'll be able to specify optimization rules. That's a little farther down the road, but it'd be awesome to throw in there like, hey, if we're doing this type of query, we don't want to really think about if it's a facet query or if it's a MapReduce implementation or something. We want to be able to figure that all out. Do we want to push down joins? Do we join to other data sets? What happens? There's a sub-project to Calcite called Avetica. Avetica is a JDBC, ODBC driver that would give us a lot of the stuff that I never really implemented in the JDBC spec itself because I didn't care when it was all kind of connecting up. But if we wanted a full JDBC implementation, we'll probably pull it from somewhere else instead of reinventing the wheel. The streaming expressions parallel SQL improvements, this Solr 8125 is a kind of an umbrella JIRA. It's got about 50 or so linked things right now. About, I'd say 40 of them are closed. We got about 10 more that just kind of push it through and fix them. And they're just little things that we found here and there and that we need to just kind of get to. And then the 8659, that one is kind of fixing some of the things like documentation, fixing some of the minor things that we've run into when we, like select star is kind of in there as a really annoying one. That there's a patch out there that just hasn't been merged yet because I wanted to make sure it was the right way to do it. But talked to some people and that's what we've determined is that's the right way to do it. All of these pieces, the info on how to get involved, I wrote a blog post about this. It's got links to all the Apache information on how to do that. Most of these are pretty low-hanging fruit at this point, so if there's any that you can help out, it'd be great. Most of the stuff you gotta get involved in, it's pretty straightforward. One of these things that is also gonna come, and this is kind of a little bit farther down with the things there, is this streaming expression join that was talked about previously, is doing joins with Solr that aren't actually like block joins and all this other kind of stuff that you have to make your index work ahead of time. This will take two different collections and be able to merge them together. So want to be able to rewrite that into SQL. We are so close right now to make this happen. And once we can get that to work, I kind of want to show what this would look like as a streaming expression. But the SQL syntax ends up being really straightforward once we figure that out. So let me just go back and grab that real quick. All of these data sets as well that I'm working with are in on GitHub as well. So I can take that same query and I can go to the Solr admin page, go to, let's just take one of these, the movie lines. Where'd you go? There you go. So I was talking about before, that was 30,000. If I just execute this query, this is 300,000. So we're actually another order of magnitude bigger on a laptop, came back really quickly. I'm going to join the movie lines with, let me just paste this in here. Movie lines with movie titles metadata. I'm just going to pull it up real quick. There it is. All right. So we're joining 300,000 with about 600 something. And what I'm going to do is go to my stream, paste this in here, and do the really cool with explanation. If you're doing streaming expressions, hit the with explanation. It's pretty neat. And this here just returned, like that joined all of that data. And so what you'll see is it queried two collections, put it to the search, interjoined it, and returned the result. Yeah, so the last little piece of this, even it works today, we just got to hook it up to the SQL syntax, and you'll be able to do joins with no problem. So any questions? I know there's going to be a bunch, so let's go to the middle here.
Great stuff. But I have a question. Why you decided to use the collection as table?
Mm-hmm.
In my opinion, I would say a collection is a schema, and a table is a special kind of document. Why you decided?
Yeah, it just, I don't know if there was a lot of, Joel might be able to know that one better, why we ended up with table as a collection.
It just seemed like a good thing to be doing because the collection is distributed tables.
Yeah.
The abstraction seems to work okay. I'm interested in your thoughts.
Yeah.
Yeah,
After the
I have, when you have Tableau or something like that, and you want to make a join, for example, customers and orders.
Yeah.
Normally in my Solr collection, I have customers and orders. And I have the type descriptor field where customers are customers and orders are orders. I have seen nobody which distributes their relational data in unique collections.
So let's talk a little about that. So you could actually do kind of like a self join and use go join the table to itself the way you're describing it. But this is really for a lot of this stuff is also going to be them saying we're going to go relational.
Right.
Okay, we're going to set up relational structures. So you can look at this as also, look at what hide does, drill does, hide. This is science.
Yeah. Yeah. So.
Every time you get involved in discussion, because we're times that we bring in viewpoints on that. I'm speaking for Joel right now. But
Yeah, I'm going to add one other thing. Is this does not make Solr a relational database. I want to be very clear on that. I've gotten that question before, and I'm like, no, not really, guys. It's read-only right now, and that's what it's going to stay for at least a little while. And so it lets you query the data that's there, but there's lots of talks on what we can actually improve in the future to make that either true or not true.
So Solr's not the goal.
Yeah.
Solr's not the goal, but
Yeah.
you don't have inserts. You don't have
Yeah, we don't have SQL inserts. Yeah.
Okay, one question. So which SQL standard you are following? Are you following every database has
Yes.
their own favorite SQL?
Yeah, so I actually don't know that off the top of my head. I know the Presto parser has whatever its syntax is. I think it's Postgres behind the scenes. The calcite piece, once we get that integrated, actually has variable syntax. Like it'll be like MySQL or Oracle or Postgres, like there's a whole bunch of options.
You support like array stuff?
Not yet. No. This is all like very. It's the parallel SQL stuff behind the scenes doesn't support like arrays or multi-valued fields, and we were actually talking about how to fix that like yesterday. So it's getting there. But that's the idea, is that we'll actually be able to support all of it.
Another question, so you have the JDBC version, which is the downloadable version you can use?
Yeah, so this is all in Solr 6. If you're using a Java project, you can actually download the Solr J Maven artifact, and that has everything you need. If you're setting up your own things, we need the reference guide has the piece that tells you what you need. You basically need the solrj.jar, and then every jar in the Solr J libs, because it has all the other stuff with it.
If you're I can just download the JDBC and just use it from my laptop?
Yeah, so you could do that here. I'll just show you what's in here, what that looks like. Yeah, the X11 stuff is like the slowest out of this, which I find hilarious. I'm like, come on. No? I'll just pull it up locally. It'll be fine. Maybe? No? Okay. Yeah, I'll pull it up in a second. Do we have another question? Yeah, go ahead.
What are your guys' thoughts on the as operator? I noticed about the double aggregation on the group by or field C.
The as does work. You can actually re-alias fields
You can
to.
use the alias field
Yeah,
already?
you can. Yep.
And you can use
How does
alias
that translate to the language then? Maybe that's there's no more pay.
So in stream expression, there's a select expression that's actually being built.
It's supported throughout the SQL statement too, so if you have a as in your column that you can sort by and group by, they all have.
But that turns into, that kind of has an intermediate state, right?
Do you-
That is
do we-
streaming.
Hold on a second. Oh, go ahead.
Is that a streaming concept or is that a SQL, sort of solar concept that's being used?
There's, no, the solar concept, this is above solar.
Yeah, it's above Solr. Yeah.
Without solar, it-
Yeah, the rename is.
And that's where we've actually started maintaining that transient state.
Yep. All right, so just to answer the other question real quick, these are the libs you need, and this is off a build with everything deleted right now. But you have, can't click out of that one. So you have Solr J, and then all the stuff in Solr J lib that gets included. Not everything's actually required here, but just do it. Otherwise, you'll run into weird problems. So just throw it all in there, and you're good to go. One thing I will mention is that Solr J does not provide a logging framework by default. So sometimes you need to throw in a logging thing here if you're using your own Java program. And then you could actually turn on real logging and get some interesting stuff other than like the SLF4J binding is not available.
So one of the big reasons for us to move from wherever we're doing our analysis was with Solr was the multi-valued field. So what are your thoughts on how we can?
Yeah. So we had some really interesting talks with about the multi-valued fields. And what does that really mean in terms of grouping or sorting, and what we'd have to fix on potentially the export handler to solve that problem. And there's kind of two thoughts here. One is that a multi-valued field, if you group on it, do you basically make it a unique string and then group on it and then return those results? Or do you put a method in there that expands a multi-valued field into a bunch of rows? And that could also solve that problem in a slightly different way.
Can we alias this as another table and just have that as a best practice?
Yeah, so right now, not yet. But that's where the CalSite piece is really huge on this, because we can actually, like CalSite will let you have fake tables and stuff that we can add in behind the scenes. And if we do that, then we'll actually be able to get table aliasing and a bunch of other kind of fun stuff, views, and that we don't have today.
One interesting side, so multi-valued fields will work in certain situations with this. So if you're using the facet approach to it, there's two approaches to SQL. One is the MapReduce approach, the other is the facet approach. To use the facet approach, you can just, it uses all the Solr or multi-valued stuff. You can group by column, multi-valued, things like that. It's only if you go to MapReduce mode that the multi-valued will work. For a lot of your use cases, you can use it just fine.
Yeah, that's true. Yeah, there's like 2 different modes in this that I didn't even cover too. So there's way more than the kind of showing off the cool fancy demos go over there.
Does the driver have to work against the cloud and Zookeeper? Can it work against just a shard? And why not?
Yes. Right now it only works against Solr Cloud, and that is how everything gets passed around is based on a Zookeeper collection string right now. There is, I don't know if there's an open Jira for that one. I don't remember off the top of my head. That to make it not work in Solr Cloud, we talked about that. Right now, I just threw a message in there like last week or something about, hey, this is a better error message than just like a null pointer exception we were getting before. It's something we could add. It's just not there yet.
Do we need to add the new SQL request handler on Solr configure JavaScript?
What do you? Can you repeat the question?
We need to set new request handler for SQL.
Oh, so do you have to set anything for this to work? No, so the SQL handler is all out of the box. The real requirements are like Solr Cloud, and then depending on what mode you're in and what your types of queries you're running, then you would need doc values on some and some other like minor things here and there. Go to the middle there.
Then we don't need the new request handler.
It will not work in standalone. That is correct. Yes.
What resources does it consume when you're talking about the last source of billion as well?
Sure. So performance of this, I guess is your question. It depends if you have high cardinality fields or low cardinality fields, and if you're going to go with the MapReduce implementation or the facet implementation. For lower cardinality, the facet implementation is really quickly. It is the same stuff that the JSON facet API is using, and it'll basically give you web type responses. So it'll come back in whatever milliseconds. If you're doing high cardinality fields, this still comes back really quickly. The number that Joel threw around last year was thousands of tuples per second exporting from a single shard.
Oh, yeah, it's like,
Yeah, it's high. I don't remember.
if you do very high cardinality, then you would go on that reason. And if you can make it go faster by going in parallel. So you would work arrays, and then partition the strings, and you can get a lot. Depending on how big your system is, you can get hundreds of millions of records per second. So you have to have lots of replicas, lots of shards, lots of sources. In order to get hundreds of millions of records per second.
Takes it up into the memory when you have high?
No, it does not. It sorts it and shuffles it and then rolls it up one.
Yeah.
It's pure, the MapReduce mode is pure MapReduce.
If you're looking for some of the lower level details on this, the talk that Yannick gave and then Joel gave last year has a lot of these lower level details on why it's not memory bound and what's involved. Go ahead.
Inject Solr, like machine syntax into your like where?
Yes. So that is one of the coolest features that I really didn't show here. Just yeah. So you can actually there's two ways to do it. One, if you do a where clause with like field A is equal to quote and then arbitrary Lucene query, and that just works. Another way is that I don't know if it's completely documented now. Is there's like an underscore query underscore field that'll let you put any query you want in there if you're not trying to do like equals and stuff. So there's so I think we're out of time on that one. So if you guys have any more questions, you want to talk to me afterwards about where we can go with this and kind of if you're interested in what use cases you have, I'd love to talk to you more. So thank you.